let's get started. Okay, so thank you very much for joining. I'm Jonathan. Today we will be talking about like how to train your self-driving car. So before we start, I think I'll say this again. If you haven't downloaded these files, you may want to download it now. So while I'm speaking, you can take time to download it if you have a slow internet. And also you can check Discord what you have to do because we have a virtual race we'll be doing later today. So perhaps like half an hour later, or yeah, something like that, 45 minutes later. So get yourself like ready and we can do something fun together. So let me start this presentation. If you cannot hear me or if you have any questions, please just ask in the chat. I will be monitoring the chat. So, okay, let's do it. So my name is Jonathan. So I'm the project maintainer of the open source project called Donkey Car. I'm also the founder of Robocar Store. We sell Donkey Car starter kit in a website. So we also promote Donkey Car as an AI education tool to K-12 students. So yeah, that is our company and our company website. So we actually design and manufacture our own version of Donkey Car. We're also active contributor to the Donkey software stack, and we have a lot of hobbyist customer coming from around the world. So people get interested in how they can train an autonomous car. So they just buy a starter kit from us and then they assemble the car and do a lot of things they want to do or try something that like ideas they have and they just try to make the car work. So we also do some teaching in Hong Kong. Yes, I'm based in Hong Kong. So we introduce this Donkey Car thing to secondary school, like maybe K9, K10 to K12 student. So we talk about this kind, let them know how it works. So most of the slide I am going to present to you today, I use it in the daily school when I teach the student. So we also do workshops to teachers so they can try their own before they introduce it in their class. So in fact, we have also done like in 2019, when the HITB Amsterdam is happening, we have put a big track here. So we have a group of people learning how to use Donkey Car and they race on this huge track, which is quite fun when we do it like 2 days, 2 or 3 days, I forget. But yeah, and then we race here and also introduce this Donkey Car to audience coming in. So it is a beautiful city and I enjoy it so much. So we also do, what we also do is like, we put the track in a big shopping mall in Hong Kong and let the general public to check what this Donkey Car is about. So, and I want to actually introduce this to you. This is there's an event called Self-Driving Global Challenge, which happened in 2019 in China. And actually, as far as I know, they want to do it every year. Because of the pandemic, they didn't do it in 2020, but this is such a very interesting event. So in this event, we there are 2 parts. One part is the Donkey Car race, and the other part is a full-size car racing. So it's not racing, it's like a kind of like a mission. Let me show you a video. Okay, so this is the full-size car. We have installed a light. They have installed a LiDAR here, and also they have a PC in the back of the car. So in this video, they are going to capture some of the data. I will show you this one. So they are trying to like capture the stop sign here. So because when they see this stop sign, they actually need to stop the car. But if they do not see the stop sign, they should not stop the car. So they are doing data collection here. So when the real challenge happening, the judge or the organizer will randomly cover this sign or not cover this sign. So they need to do this, and when they stop, after they stop here, they can proceed to the next checkpoint. So it is a lot of fun if you are interested in autonomous driving. So like you can actually join this self-driving global challenge next year. I hope next year, like 2021, like in fact, they sponsor people coming to China. You don't actually have to pay for anything. They sponsor the air ticket, they sponsor the accommodation, everything. So if you're interested, let me know. And if they are going to organize it next year or anything, I will let you know. So I also actually blog this in Medium. So you can check this out. I can paste the link on Discord and here. So you can read it later. So I actually blog what we are doing in this like a garage things. We have like this vehicles we can use for like install and program things inside the car, and they have all kinds of sensors, cameras, the PC here, and I have also described the challenge. You can refer to it later. Okay, great. So let's talk about what is Donkey Car. So Donkey Car is very simple. It's actually an open source driving platform. It runs on Raspberry Pi. You can also put it on Jackson Nano. It has a camera. It has Python code running on the Raspberry Pi, and also it uses TensorFlow. So by using all these, you can achieve autopilot. So how does it work? All right. So on the Donkey Car we are going to sell in December, we are going to release a new version. It also comes with a controller board designed for Donkey Car, so it can support a lot of things. It has a NeoPixel, which is kind of a programmable LED light, and also IMU and also other sensors there. So we have used this in our new release as well. And actually, because Raspberry Pi is not very powerful when running like a neural network, very heavy neural network, or even if we talk about object detection, it can't actually run it very smoothly. So we can also attach a Google Coral USB accelerator to the Raspberry Pi to accelerate the inference. So we can like doing all those kind of object detection pretty smoothly. Okay, so let's talk about how Donkey Car work. So it is a very simple three step. So we first collect the data, which is actually at this cycle today, we're going to experience it using the simulator and also the virtual Donkey Car. So we first collect the data, and then we also train the pilot, and then we test the pilot. If the pilot is not good enough, we collect data again, train our autopilot, and then we test again. Okay, so today we'll be using a mobile app, okay, and also using a virtual Donkey Car together with a simulator. So first, the Donkey Car take a picture. In a real Donkey Car, it will use the camera. Today we'll be using the scene generated by the simulator. And we also get your input. So you will be driving the Donkey Car first to collect the data. And then in a real Donkey Car, they will update the server. For our case, it will update the simulator, how much throttle and how much steering we want the car to go. And actually, the software will save that piece of images and also the input you're sending to the car. Okay, so we keep doing this driving inside the simulator, and we want to collect like 10 to 50K record. Okay, And by the use of like a Keras and TensorFlow stuff coding here, at the end, we can generate an output of the steering and also the throttle here. So we do some training here. And then when we do autopilot, we give an image input to the neural network. And going through all the neural network, the system will give us a throttle out and angle out. So we just test, drive, repeat, continue this loop. So at the end, we test whether the autopilot is doing good or not. Okay, so there are several kinds of machine learning. So we have supervised learning, unsupervised learning, and reinforcement learning. So in this case, since we are providing input to the image, we teach the car how to drive while the car is recording the image. We are actually tagging our driving skills or driving habit to that image. So this is supervised learning. So we will also talk about reinforcement learning later today. Okay. So the software and the community. So we have a mobile app called Donkey Car Controller. So we built this Donkey Car Controller because like to be used for this to be used in school, normal student wouldn't be like that skillful typing commands and etc. and etc. So we built this mobile app, and the student can complete data collection, driving the car, check the data, they can train the model and do autopilot in one single app, which is we are going to use this app later today. Okay, we also have the documentation. If you go to like here, okay, so we go to docs.donkeycar.com. You can find all the a lot of documentation here maintained by the community. So there's a lot of useful resources here. If later on you feel interested, you can go through all the docs. Yeah. Okay. So Donkey Cars is an open source project on GitHub. As you can see, it has like, it's actually one of the most popular self-driving library. We have like a 2K star, I think today we have 2K star here. And then we have like 3,000 members actively exchanging ideas on Discord. So we also have this simulator we will be using today. So we can do standard Donkey Car drive train test cycle. And I will show you how later. So it also supports that if you're not using Donkey Car software, you can use other kinds of software and then join the virtual race together. So talking about virtual race, actually the community is doing a virtual race league every month. And we can do like AI versus AI. Most of the time we are doing AI versus AI. And then and we just try to see which one who is the best AI can train the best AI agent. So before we do the virtual race, I want to talk about self-driving car for a while. So when we talk about like self-driving car, we always want to introduce something realistic in the real world to the students. So we know that on the left-hand side, it is Tesla. On the right-hand side, it is called it is developed by a company called Waymo. You may not know Waymo very well, but you must know its parent company. Its parent company is Google. So when we talk about self-driving car, we always talk about Tesla because Tesla always claim that they have like a autopilot function, right? And Waymo, we heard a little bit in at least in Hong Kong, not a lot of people know Waymo. So we also talk about self-driving levels. So so this diagram actually describes, because there are when we talk about self-driving, people always talk about level 1, level 2, level 3, level 5. So I also want to introduce this concept to you. So level 1, 2 is not actually like autopilot or self-driving. So you can see that both hands needs to be on the wheels. Okay. On the level 3, you can leave one hand on the wheel. On the level 4, you can leave both hands leaving the wheels. And level 5, maybe in future, you will find a car without a driving wheel. So you can check this self-driving in levels later. You can Google it, but generally you know what it means when people talk about self-driving. Okay. And there's a lot of like sensors in a self-driving car. Something you may be more familiar with, like GPS, ultrasonic, something like odometry or LiDAR. You may heard about it because like the latest iPhone 12, it has a LiDAR. So we have all kinds of sensors in a self-driving car, including cameras. So for example, Tesla, they rely heavily on cameras and other sensors, ultrasonic or radar, but they do not have LiDAR. And if you can compare it, Waymo is using LiDAR. So there's a great debate on whether self-driving car would require a LiDAR or not. And for your information, LiDAR is extremely expensive. So you can imagine why Tesla is not using LiDAR, because actually Tesla is producing a lot of car every month. Compared to Google, Google is just manufacturing like a small fleet of cars for its prototyping. So in a practical term, Tesla cannot add LiDAR to their car because like it would be too expensive for them to do so. But for Waymo, it's okay because they're not actually mass produce their self-driving car. Okay. So this is LiDAR. So I would like to go through very briefly what LiDAR do. So you can see that there's in the simplest term, there's a laser beam scanning the whole area. So we can see a cylinder here, and when the laser beam scan the surroundings, it scans that, okay, there's a cylinder here that may maybe in my way or something that I should take note. So in this car, we also have a LiDAR here. This is, if I remember correctly, it is a 16 lines LiDAR. So it constantly scanning its surroundings. And this is a closer look. So we can actually, when we drive through, this is pictures I take when some of the people, they're driving the car. I just show you around the whole campus. We are doing the self-driving challenge. They use the LiDAR to produce this digital map. So they can scan all the surroundings and produce this digital map in order to do path planning and also make sure the car is running on the right position, or is like driving in the right position and not crashing into a wall. So this is something that is done by the LiDAR and also the software to generate it. Okay. By the way, I also want to talk about like this is it's an estimated Tesla autopilot miles. What it means is that actually Tesla is using all the car they sell to collect driving data anonymously, and this is how many miles they have collected in 2019 and 2020. So they have I think they have the biggest database of real life driving miles that could help them theoretically or practically to train their autopilot system. Okay. And I also want to, I also will talk about the social impact when autopilot or self-driving car is become like a real thing in the near future. So I always talk about this picture is that when we have real self-driving car, this guy who is it's kind of a police officer is in Hong Kong. So what these guys do is to see who is doing illegal parking, and they will issue tickets to the car. So in future, actually, if everybody is using autopilot or self-driving car, imagine if you have a self-driving car, you won't be like parking illegally. You just tell your car to send you to your office, and then you get off the car and the self-driving car will maybe head back home or do something else. There are some interesting things that people can people think about. For example, is that after your self-driving car send you to office, probably you may not want it going back home because it will, use some of the gas or electricity. Perhaps you will send it to a very nearby car park to park there. Even better, people suggest that if I can send my own self-driving car as a Uber to earn money while I'm working in office, it would be perfect. So this is something that like people has been suggesting when self-driving car become a reality. So we will also have some other like implication that is quite interesting. So maybe we won't be able to own our car because like Tesla would not be selling cars to us. Other self-driving car vendors or makers, they will operate their own fleet and offer us transportation services instead of selling us the car. And we actually we don't need car park space in buildings or on roads. And since no one is buying the car financing industry or the insurance industry may go away, and a lot of lawyers may lose their revenue because there's no longer a car accident or something that people will need to claim or sue each others. But on the bright side, like senior citizens, some of the senior citizens in Hong Kong, like my father, he actually need to renew their driving license every year because of the age. So in Japan, some like elderly, they lose their driving license because their physical ability is not allowed to drive like a machinery like the car. So if we have self-driving car, their life will be greatly improved and their social life could be maintained because they can visit other people using the self-driving car. These are some of the examples that people will talk about when a self-driving car become a reality. And also, because of self-driving car is happening, there are other topics that people talk about. For example, what decision should the self-driving car make? For example, in this picture, there are one dog and one cat driving towards a group of human beings. So if the car drives straight forward, and then it will kill all three of these people. And if the car turn left instead and hit this speed bump or something like a concrete here, then it will kill the passenger on the car. So in case of a mechanic error or failure, what would the computer do? Would they kill the human beings on the road, or they kill the human beings or other people on the car? So there's a lot of scenario that this moral machine from MIT that they want to crowdsource our decision and put it onto a self-driving car. Okay. So, and this is a very interesting video I want to show you. It's about like Tesla. So let's pause this for a while. Let me give you some of the context what this is happening here. So we see a Tesla Model 3 here, and actually the owner is trying to test one of the feature offered by Model 3, which is called the summon function. So the summons function is used when you go to the shopping mall, because like in some country, the shopping mall is extremely big, and sometimes the car park is also very big, and you only park in the Tesla or your car in a very far away place. And Tesla has a function that you can call your car to pick you up when you have a eyesight contact with your car. So you just press the app, and the car will drive autonomously to you and to pick you up. So you don't have to carry all those heavy groceries back to where you park the car. So this guy is trying to test the summon function, but something happened. Let's see what happened. Okay. Okay, let's turn on the sound. Okay, can you guys hear the sound? I just want to make sure, because
yes.
Yeah, okay. So you can see that it is driving autonomously, and they're filming the thing. And note here, there's a white line here. So let's see what's happened. The white line means that the car should stop before the line. So we saw a police officer actually see this happen, and the Tesla is still moving, and the police officer asked the Tesla to stop.
All right, that's not good. The police officer just pulled over the Tesla. It ran the stop sign.
But the police officer cannot find the driver. So they have stopped the summon function, and the police officer came to check where the driver is. Okay. So it's funny because he cannot find the driver. So they're explaining to this officers that this car is running autonomously.
Yeah.
Yeah. Okay. So actually, we won't go through all the videos here, but I just want to ask one question. Legally, so who get the tickets? Obviously, if I'm using that function, I shouldn't be the one who get the tickets, because I don't design the autonomous function. I would not anticipate that that Model 3 would not stop before the white line. So would it be Elon Musk getting the ticket, or the director of AI in Tesla get the ticket? So this is something that we can discuss or even debate. So yes. And also like security. So there are some researchers adding like modifying this speed limit size in order to trick the car seeing this sign. When they see this sign, they may have mistaken this sign as 85 instead of 35. So imagine in a very busy town, or in the area of a hospital, what if people like messing around with this sign? May what will happen, and how we should like avoid this. Okay. So talking about like donkey car, we also have something like later on today, I can show you something like this is some kinds of technique we will be using. It's showing a footage of we are driving in a remote control track in Hong Kong, and we are doing some kind of something called Salient Visualization, which tell us which pixel actually trigger the autopilot action. Okay, and in Donkey Car, we also have developed some kind of voice control here. Then we can play. So we can talk to the car, and the car can start autopilot immediately. So we can also do speed up and slow down to control the car. So this is a donkey car running on the track. Okay. We also do a stop sign recognition with donkey car using the Google Coral I just showed you. So the donkey car will stop hopefully before this stop sign, because it is analyzing if there's a stop sign nearby. When we take away this stop sign, the car will continue moving. Okay. So I also want to share with you some of the video I think which is quite interesting. So this is the director of AI in Tesla. So when we just talk about stop sign we do in donkey car, you would think that this is a very easy task, but actually it may not be that easy. And let's hear why this is difficult.
It's quite difficult when we get to the long tail of it, even to create a simple detector for a stop sign. So first of all, stop signs can, of course, be in lots of varying environmental conditions. Stop signs can not just be on poles, but just like on walls. Stop signs can be temporary and just hang out in different configurations. Stop signs can have funny light in them, which are supposed to make it easier to see the stop sign, but for our system it's the opposite. We have to actually explicitly worry about it. Stop signs can be held by a person. That stop sign can be in an inactive state or an active state. Stop signs can be on like these cones. Stop signs can be heavily occluded in lots of ways, by foliage, by signs. Stop signs can be occluded by cars. Stop signs can be part of cars, and they can be part of cars in an active or inactive state again. Stops can be sort of held by a person. Stops come with lots of exotic modifiers to them. So this stop only applies except right turn. This stop says take your turn through this place. This stop is right turn, keep moving. So do not stop if you're going right. So there's a variety of modifiers, all of them we have to care about because they actually have impact on how you should drive through this part of space. And as I mentioned, everything is AI vision based at the moment. We do have maps, of course, that we build, but they're not high definition maps. But stops can be attached to gates, but they only apply when the gate is closed. When it's open, they do not apply. Stops can be in arms. These arms can lift, and then the stop sign does not apply anymore.
So I would just stop here, and you can actually realize how difficult it is if you're working on like a self-driving car. Even a stop sign, you can see that it is actually not easy to cover all the case, and in fact, in a real world case, you can see like stop sign like this, and you need to figure out a way to solve all those stop signs. So there's a thing called reinforcement learning as well. So in this picture, do you remember these two guys? So one of them is representing a company called DeepMind, and the AI, which is there's the AI playing chess with this like I don't know what is this English. So this is kind of like a world champion or champion or something like that. So the AlphaGo, the AI AlphaGo is playing chess with them, and he easily beat this guy and also the world champion later on. So reinforcement learning, we have heard AlphaGo, and there's something called AlphaGo Zero as well. So I would like to show you this. this pictures is saying that there's a this AI AlphaGo 0. In 3 days, it surpassed the ability of AlphaGo. And in 21 days, it also surpassed another AlphaGo variant. So in 40 days, it beat everybody in this earth, on this earth, including all the AIs. So reinforcement learning is something like about maximizing reward. So the AI is learning by himself, figuring out what is the best strategy to maximize this reward. We don't tell it how it can achieve the result. So in a layman term, it is achieved through trial and error. Of course, underlying the policy or the algorithm is much more complex, but in theory, so this is what it is doing. Okay, so in Donkey Car, we can also train a reinforcement learning agent as well. So this is we have trained something like a reinforcement learning agent inside the Donkey Car simulator. It is doing something very funny. If you notice the front wheel of the car, it is shaking. So I want to ask you, why is it shaking? So basically, we define a reward function and is trying to maximize the reward. The reason it's shaking is interesting. It is closely related to the reward function. So in the reward function, we asked it to get as close as the center with the center line as possible, but at the same time trying to extend the time it can do on the track. So by doing this reinforcement learning, the agent actually realized that by turning left and right, it can actually extend the distance it maintains on the track, while it can also stay as close as the center line. So it's actually a bit scary because it finds out a way that most of us may not have imagined of. Okay, so there are other questions as well. So supervised learning versus reinforcement learning, which one is better? Or can a reinforcement learning agent trained in a simulator runs in the real world? So we put agent training inside a simulator. They can train numerous hours inside a simulator. But how about if we put this back to our real world? Will it work as well? So this is one of the questions people is asking and also trying to make it work. Okay. So at AWS has also created, they released a card called Deep Racer that rely on reinforcement learning. If you're interested, you can check out AWS website. It is called Deep Racer. It is pretty interesting as well. So, okay, that's it for the presentation, and I want to move to like our virtual race, but let's have a break for 5 minutes. So by doing the break, I need help from you. Please let us know if you want to participate on the race. If you want to participate on the race, please sign up for the race first. We have a Google form, which is on Discord and also the chat of this Zoom meeting. So please sign up there, and we will teach you how to set up a virtual donkey car and also join the race. Okay, let's have a break. We'll come back on like 8:55 in my time zone. Okay, first sign up the form and then install stuff on your PC. If you have any questions, feel free to ask us on the chat. Okay. Great. We have 3 people signing up already. So I can see that there are 2 people who is using Windows, right? So do you guys have the Docker installed already? Hi, Dillian. Thanks for joining. We are having a break now, and we will resume like on 8:55.
Sounds good. Sounds good. Sorry, I'm late.
No worry. You're just about time. You can join the race.
Yeah, I was watching you guys on Facebook. It was awesome. Good stuff.
Yeah. So, if you want to join the race, please sign up.
Yeah.
Okay.
Sure.
Yep.
Sorry, I don't know how to pronounce your name, but your Docker isn't working. Okay. Right. I can help you later when we start train Navnev, right? Okay. Cool. So take your time. We are having a break, and you can also install the Docker, the mobile app, and download the simulator. So when is the race? It is going to happen like 5 minutes later, but I will show you how first. It will take me take us like 20 or 25 minutes to show you how it works, and we can have like 30 minutes. You can train your car, you can run the simulator. Okay, so it would probably happen in next 5 minutes. I will show you how first. Just get yourself ready by installing the Docker, the mobile app, download the simulator, so you can start right after I tell you how to do it. Okay. So how other people do you have the Docker installed? Do you have the mobile app installed? Are you installing? Please, if you can tell us on Discord or Zoom. Are you guys ready? If you guys ready, we can proceed. If you need more time, let me know. Okay. Great. You can't have the mobile app running today though. Okay. You can still do it, but it will be a bit difficult. Is there any reason why you cannot install the mobile app? Okay. Don't worry. Let's for all those technical issues where we can deal with it after like I show you how to do it. Okay. So what we will be doing today is like we'll first create a virtual donkey car using Docker and install the donkey car simulator. It is very easy to install the simulator. You just download it, extract it, and then you double click it. It will run both on Mac, on Linux, or on other thing. So also we drive the donkey car in the simulator using the mobile app. So that's why you need the mobile, because you need to drive the car using the mobile app. And then you will collect data for training. Preferably you can collect like 10K images for training, and then you will use the mobile app to train the autopilot as well. So by using the mobile app, it means that it will send data to our training server. So it will be much quicker than you training locally, and you will get autopilot model in like 5 minutes. And then you can test the autopilot model in the simulator, and then you can send that model to me, and I can get all your autopilot model and show you like how your model is doing against other participants. So okay, so this is what we are going to do today. So please download the app. If you can't download the app, it will not work, at least for now. Okay, you can find the QR code on the Discord pinned message as well, where I've put it there. Okay, just use your phone to scan this QR code and download the app. So also, please clone this GitHub project. It is a project developed by me, and then it will help you install the donkey car, virtual donkey car, much easier. Okay, so if you go to Discord here, you will see that there's a Git here. Just click this, and you can find git clone command here. Basically, if I'm going to do the same thing here, okay. So let me go to tab, and then I just paste this here. So it will download this project onto your local PC. So what you need to do is open your local terminal. If you don't have Git installed, maybe you need to install it. After that, you just clone this okay, so you can see that I have this donkey car Docker. Okay, donkey car Docker here. Okay, so if you do not have Git, alternatively, you can just paste this command here, remove the Git code, just go here, and then you can download the code here by downloading the zip. Okay, so you download this project, and then after that, we can check what's inside there. So let me show you what's inside. You don't actually have to open it, but I'll show you. So this is the donkey car repository you just download, and there's a start.sh or start.bat inside the root folder here. So it may be a bit blurry, so let me make it bigger so everybody can see it. So basically, it is going to pull a Docker image here from the Docker Hub. This is an image I prepared, and then it will call Docker Compose to bring up the images, okay? And then it would run some commands that would set up, okay, sorry, it would run some commands and set up the environment. So this is basically what it does. So if you're curious, we can also check what is in those Linux Docker Compose file. So basically, it run these images and open 2 ports, and then mounted this my car folder to inside these images, define there's a web controller port, which is 1887, and then that's it. So since this is a security conference, I would also go through this Docker file so that you know, what is actually inside running this image. So we actually use a Python image-based image. We git clone the donkey car official repository, install some dependency here, nothing fancy. And then we install the donkey car library and also TensorFlow. And also we install some other dependency which help us generate some videos, good looking videos, and also install the donkey car simulator supporting library here. We also installed this donkey car console, which help us to communicate between donkey car and the mobile app. You can check this open source repository as well. We develop it together with the mobile app. And lastly, we just run the donkey car console, which accept connections from the mobile app. So this is what this Docker files is about. So basically, after we use this start.sh, it will run a virtual donkey car in our system. So let's try it. So let me show you what would happen. So we are in the right project. So donkey car, we have like a start.sh here. So before I do, okay, I need to stop some donkey car I have previously started. Okay. So basically I stop all the donkey car containers I run before, and right now I have nothing running. So when I start the donkey car here, I would just do a start.sh. If you are on Linux or on Mac, you can do it relatively easily, and you can see something happening on your PC after you run start.sh. If you are on Windows, it is actually the same after you install all the dependency, which is start.bat. It is also using Docker Compose, and it will also start a virtual donkey car. Okay. Great. So you can basically, if you have installed the dependency, you can do what I'm doing now by using start.sh or start.bat to run your donkey car locally. Let us know if you cannot do that. So after running that, you can see this is the output I just shown you. And then we can run a Docker PS to check if donkey car is running. So if you can see here, I've got one container running. The image is the donkey car here, and it is created a minute ago and is listening to these ports. And the image name is called donkey car. Okay, so let's do it now. If you have any problems, let me know. This is the first step we need to do. If you have any problem, just ask in Zoom chat or the Discord. Okay? If you can't run it or have any questions, just feel free to ask. So someone has Docker not working. Can you let me know how it is not working? Do you have anything can you do a Docker PS? You can send us a screenshot on Discord, and so we can help you. Just open the terminal or command prompt. Okay. So you're on Windows, right? Great. So what does it return when you do a Docker PS? For others, can you let me know how it is going? Is things moving good or smooth on your end? We have we have 4 people signing up. Yeah, if you have any question, you can ask us and we can help you set up the donkey car. Okay. I remember I saw this error message earlier. Let me help you. So how about others? Great. So YD does when you issue the command docker ps, can you see something like this? You should be seeing something like this. Great, great. So how about the other 2 guys? Do you have any success running the command? Cool, cool. So, right. So following. And how about Rammer? Rammer, are you here? Will you join the race? Okay. Great. So I will help you later on the Docker things. I will just show other how to advance to next steps first. So if you install the mobile app, so you will see that the mobile for the first time will ask you to accept some kind of agreement. You just click skip network setup. The app will actually start looking for the virtual donkey car. Okay. It will trying to scan the network and try to see if it can search the donkey car you just installed using Docker. Okay, so for the guys who can actually use the Docker image, can you use the mobile app to scan the network so they can find the donkey car? If you can do it, please let me know so I know you're following it. Okay, you can see the virtual donkey car by scanning the network. Okay, homework. Okay, good. Okay, so basically after you launch the app, you can actually find the donkey car, and then when you tap the car, you can actually see a dashboard like this. Okay, so there's a number of buttons that you can use here. The first one is drive. If you tap drive, don't tap it yet, but if you tap it, it will prompt whether you want to use a virtual controller or a virtual joystick or physical joystick. Let's not tap anything first, because at the same time, we actually need to launch the simulator. So by launching the simulator, it is relatively easy. So let me show you how. So here I have got my simulator extracted here. So I have a lot of different versions, just ignore it. So I can just double click this donkey sim.x86 64, something like that. So if you cannot double click it, so I double click it, it is launching. If you cannot double click it, there's a problem that you may want to do is change mode plus X donkey sim. You need to issue this command. Okay, so how do we on Windows? It is not necessary. It is only required in Mac or in Linux. So if you go to the simulator page, you can see that there's an instruction to install on Linux or Mac OS. You need to execute the following command. So after downloading this zip, okay, so I have it extracted here. For example, on Linux or Mac, I can open the terminal here, right click, open the terminal here, and I can just do a change mode plus X donkey sim.xat. So it will just make this executable, because previously, if it is not executable, you might see something like this. Okay, let's do it. Okay, it will say it cannot display. So we actually need to change mode plus X so that this would execute. Okay, so we have successfully executed the donkey simulator. So I'm using a version 2011-13. You can also use the version just released as 2011-17. Both are fine. So right now I have the simulator running. I also have the virtual donkey car running. So I will be using the mobile app to connect in. Let me check if I can also use Zoom to share my mobile app screen. Give me a second. Okay. Let me find out the Zoom link here. Okay. Right. I'll just paste this on our Discord so I can easily find it here. Okay. So let's try if I can actually join in using my phone. Okay, I'm joining in. Okay. Okay, I will make myself able to, I will just share. Sorry, give me a second. I will allow share screen. Okay. I will stop sharing for the moment. I'll try to share my screen here. So can you see my screen now? All right. It looks like it doesn't work as I expected. Sorry, guys. So don't worry. I will just launch the mobile app without you seeing it. So let's get started. So when I launch the mobile app, I actually can scan my car and then I hit drive. So when the moment you hit drive, you will see that the simulator will go into a track. So can you see that? So on the simulator, you're seeing like something like you're playing a video games, and at the same time, your mobile app should look like this. So this is the simulator, and your mobile app should look like this. So it is like a joystick wheel that you can drive. When you drive, the simulator is also moving. So the left knob, you will be using it to control the throttle, and the right hand knob, you can control the steering. So you need to actually spend some time to practice the control. And on the right hand side, right upper corner, you can see like a recording button here. So when you press it, like now, the system will start recording data. Okay, so you use the record this button to start recording, and do not stop until you have like 4,000 or 5,000 images. And use this button here, this cross, to exit the driving UI when you finish recording data. So when you finish driving, tap the exit button. It will show you a driving summary. So it shows the number of images here that you have collected, the size of the data you have collected, and also the histogram of you driving. Okay, when you finish using the mobile app to drive. So how to read the histogram? So this one, it means that user angle means that the steering distribution throughout the whole driving session that you drive. And also this is the throttle, is also the distribution. Okay, good. So after we have collected data, we can finish driving, we can go to check the data. Okay, so there's a terminology called a top. A top is like a logical collection of images. So for example, on this top, we have like 400 images. On this top, we have 300 images. So each time when you initiated a recording, then you created a top. And these are the images I previously collected. So you can use this button. You can tap here and check the images you have collected. Okay, and you can actually check the data you have collected. It can play back a video, and you can also review the images here. Okay, so after you have collected after you have collected the data, you want to start training an autopilot model. So you tap here, the train button, and then you select the top you want to train. So basically, training is like making a brain. You provide tops, which means book for the train to learn. Okay. On the upper menu, you can tap the plus button, because in this screen, when you start training, basically you do not have any existing model on your virtual donkey car. So you will be using this button to train your first model. You choose the data you want the model to learn from, which is the top, and then you just click train, and then you submit. So minimum number of images is 2,000. If less than 2,000, the training will fail. So normally we recommend you training using 5,000 image. And the training process will happen on our server, because like if it happens on our server, it will train much faster than you training on your PC, especially if your PC do not have the GPU required. Okay, so when you submitted it, the system will show you like first the job is scheduled, and then when it start training, it will like say that the job is training. So it would like take like 5 to 10 minutes to finish each training, depending on the size of the data set. If you give us like a 20,000 images, it will train much longer than a training with 5,000 images. Okay. So after training, you will see that the system will give you a summary of what is trained. So this is like a normal TensorFlow chat that shows that the training data accuracy and also the validation set accuracy. So, and then you can see a button here and you can start the autopilot right away. It will approximately take 20 seconds to start the vehicle in autonomous mode. Okay. And the autopilot UI will look very similar to the driving UI, except there's a drop down here. Let me show you the next picture. So this is a picture I took earlier. So this is a screenshot. So there's a drop down menu here when you start the autopilot, and then you can check this. You can click this menu and then switch the car into autopilot. So I will show you how later. So your car would be running similar to the behavior as you drive. So in real car, there's a big emergency stop button, but it doesn't matter in simulator, right? Even if we crash, it's all right. It doesn't matter. So it's all right. And you can exit the autopilot mode by using the X button on the upper left corner. So in the simulator, we just show you here. So basically, there are 5 tracks, and we are using the generated track. Okay. So once you finish training your model, you upload it to the share drive. So Alice, who is also in this meeting, she will share the link that you can upload your model. So I will share with you how you can find your model. Okay, let me do some demo to you. Okay. So we have our simulator here, right? Okay, this is not a screenshot. This is a real car. I am using the mobile app to control it. So let's try driving slowly. So I'm using the mobile app to drive this car slowly, but I have yet started the data collection because I need to practice it more using the mobile app. And then after I am totally comfortable with this, I will start recording. Okay, so I think I'm ready now, and then I'll just use the button I just showed you to start recording. On this screen, you will not be aware that I have already started recording, but later on, let me show you where the recording is. So I have been recording like, for now, I have recorded like 400 images. Yes, it's pretty quick. You would not imagine that you can record it so quickly, but it is really that quick. So I canceled, I just stopped driving, and I have like a number of images, 500 something. I take this screenshot, and then let me see if I can share this to you on Discord. Okay. So I just finished it recording, and then I just upload it on Discord. You can take a look here. If possible, yeah, let me know you have checked this. So when you leave the driving screen on the mobile app, the simulator would become like empty now, and basically you can exit it or you can just leave it there. Okay, so just now I have told you that we have collect 500 images. So where are those 500 images? So if you go back to the project that you used to start BAT or the start SH, you can see that there's a folder here called My Car. I'm sorry, in my folder it's a bit messy. There's a My Car 1, 2, 3. You may not have that one, don't worry. So let's focus on My Car. And under My Car, there's a folder called Data. So again, I'm going to make it larger for all of us. So just now, if you can see that on Discord, I have a tube called Tube 23. So inside Tube 23, we have a lot of images here. I can just randomly pick one. this is what I have recorded just now. And we have like 500 something images, right? So if you check here, we have 545. So this is the 545th images we have collected. And you can also check there's a bunches of JSON file created. On each JSON file, actually, they are recording like at that moment for this particular JPEG, what is the user angle, which is the steering, what the user using. For 0, it means that I'm running on a straight line. So for the throttle, I'm running like a 0.4, maximum is 1. So basically, I can find 500 JSON file here. Each represent the state of how I drive when that picture is taken. So basically, it's something like that. Okay, so we can find all the data we have collected here. But you don't actually have to worry about it because the mobile app is helping you to manage this data folder, as I have said. So basically, okay, you can check the data here instead of using Visual Studio Code to go into each top. Instead, just tap here and then it will show you all the images you have recorded. Okay. So after recording the images, you can train the model and then you can test autopilot. Okay. So, okay. After you have trained an autopilot model, as I said, you can use this button to start it. Okay, the mobile app will help you automatically download the model from our server. So if you see here, there's another folder apart from the data folder. There's a model folder. So it will save all the jobs you have submitted previously here. So we have a job 1 here. So which we can, which is something I trained earlier. So after you have trained it, most likely it will be called job_1.h5. If you're happy with that, the performance of that model, you can upload it to us, and we will be using that model to represent you to drive. Okay, so it is that easy. So if you have successfully installed the virtual donkey car, and you can now so you have like 30 minutes now to collect at least 5,000 images and train the model. You can do it using the app only. You don't actually need to use Visual Studio Code, just like I just showed you. I just show you for the sake of understanding how it works, but you can just use the mobile app and train the model and test that model by connecting to the simulator. Okay, so right now, what's the time now? So it is 9:30 now. We will be starting the race at 10. And in the meanwhile, if you have any problem, I will be helping you to solve the problem and hopefully get your virtual donkey car running on your PC. Okay, we have 30 minutes, and then please collect 5,000 images and train a model. Okay, if you have any question, just send the questions on Discord and I will help you. Okay. Okay. So let me try to help you to solve the Docker issue. I'm reading something now. Give me like 1 or 2 minutes. For the rest of people, can you let me know whether you have issue doing this? Because I haven't heard from you yet. Hi, Leo and Eld, are you joining the race? I'm sorry, I just helped another guy to solve the problem. Are you joining the race? Do you need help?
No, sorry, I'm a bit late, so I don't think I'll be joining the race.
Okay, all right. Yeah, if you want to join, I can show you how. Yeah, but it's up to you. It's perfectly fine if you just want to stay with us.
Yeah, sure. I'll watch, I guess.
Okay. So because we don't have a lot of like people joining the race, so let me show you something like so what is it like when we start autopilot? So okay. So here I have a job underscore 1.h5 in my car, and like I can use this model to run an autopilot, and I will just show you how. So I have the simulator ready. Okay, and I also have the Docker running, right? So right now I can either start the autopilot using the mobile app, in which let me try this first and show you. Okay. So, okay, I have only one model trained 2 weeks ago. Let's try what this is. I don't think it can work on this track, but let's try. No harm, right? So I have been loading a model. So, okay, good. So the car is almost ready. So I will switch to autopilot mode, but most likely it won't work because I think it is not trained on this track. If this is not trained on this track, it will behave something like that and hit the cone. Okay, so let's go back and find a model that will work. So what do you mean by finding a model that will work? In fact, so I have a model here called Jonathan, so which is something I trained earlier. Alice has also trained another model. So basically, I just copy this into here. Then I will have a new model in my virtual donkey car. And I can start the autopilot again by using this model. Let's see whether it will become better. Okay. So the car is initializing. And let me choose the autopilot mode. So you can see that this car is on the autopilot mode. Okay. And it is actually now running autonomously. So because I am starting this on the app and you cannot see my mobile phone, so it is a bit like confusing like what we have done, and it just happened like magic. So I would just quit this autopilot and let you know how I would do it by using commands. So I quit this first, and then I go back here and start manually. So, okay. So here we have my car here. Okay, let's check. Inside my car, I have a model directory. And then we have this Jonathan.h file, which is a model I trained it earlier today. So in order to run this, excuse me. So let me get the right command. So basically what I need to do is to run a command inside the Docker. I need to modify a bit and ask it to use Jonathan.h5. Let's see if it works. So by executing this command, the Docker will try to find, okay, it is there already. Okay, we have a bunches of like things here running. So, okay, you can see that we have like an autopilot running here. So let's go back to this command and let the car just drive. So we ask the Docker to execute on this container, this command. This command means you use Python, we call manage, call file, call manage the py, and then ask it to drive. And then we're using the model called model/jonathan.h5. So it will load this model and start the car automatically in the simulator. Okay. So if we hit Control-C here, the process will be terminated and the car will go away. So it's just like this. All right. Obviously, I'm wrong. I need to also kill the process as well. Let me just stop the race. Okay. I just killed that process and it is done. Right. If I put a flag called interactive, I think here I can Control-C the donkey car and terminate the process. So I reload that model. With this model, I specify Jonathan.h5, it will run automatically. So because I know that, so let's cancel this car. Okay, it go away now. So let's see what other models are available inside my car. So we have this job1.h5. So actually we can try to use this job1.h5 and see if it crashed. Normally it should crash because this is a model we just have seen that it's not working so well. We're just trying to verify that this command will load another model. Okay, here we go. So let's see. So it should not work that well. Yes. So it will crash. So because we are loading another model that wouldn't work very well on this track. So we just cancel it. And then going back to use the Jonathan.h5 model, it should be okay to run this track. And because we have a model that runs pretty well on this track, we can actually even create multiple cars using the same model, but on different donkey container. Because right now we don't have anyone else asking me questions. So let me show you this. Okay, I just stopped this Docker container. Okay, so right now we have no Docker container running. So I have another script here called multiplayer, which will create like whatever numbers of racer I want. So I just type, perhaps maybe I should try 4. I have never tried 4. So let's do it. So you can see that it is creating multiple donkey car container here. Great. So let's check. So we have actually 4 donkey car container running simultaneously. By running the container, it doesn't mean that it will appear on the track, but it means that it will be ready if we tell it to do so. So I also have this like start NPC stuff in my local repository. We can check what it is before we run it. So we want 3 NPC. NPC means like a computer, and we can start like this number of car simultaneously. Let's see, we have a job underscore 4 here. Let me try to copy this job underscore 4 into each car so that it will learn how to, it has the model to run. Okay, give me a second. Let me demo this to you. Okay, I will need to copy and paste this too. Okay, no. So I have a car for here, models. Okay, I'm not allowed. Okay, don't worry. I will just start 2 car. Perhaps 3 cars, why not? And starting from the first car. Cool. Okay. So when I do this, let's try if it works. Starting first car, starting second car, starting the third car. Right. So we can see that we have like racer 1, 2, 3 ready, and each of them will start running on the same model. Can you see that, Leo? Because like,
yeah.
Cool. So each of them is running separately, but using the same model. Okay. So basically we created 3 NPC racing each other, but since they're using the same model, basically they aren't able to like overtake the other car. Okay. So I have actually trained an agent that race with this 3 slower agent and practice how to overtake them. So let me show you. Let's see if I can show you that. I see that there's another participant coming back. Have you solved your Docker problem yet? Or you need more time? Okay, I'll just give you more time. Okay, so let's
just a question.
Yes, please.
So since they're running on the same model, that means they're running the exact same race, or are they running different races?
So they're all connected to the same simulator. In fact, each model will see other two cars as well. So they're running on the same track. Just that, and you can think that they are running on the same brain as well. But just like each brain may react to different scenario, because there is always some kind of physics that is creating some kind of a bit different, and then their reaction will be a bit different. So they are not running identically, but they are running nearly identically. If you are checking the race line here, I think Racer 1 is the first guy. So you can see that Racer 2 is actually running in a very similar race line as Racer 1. So Racer 1 keep the left lane here, and you can see that Racer 2 is also keeping the left lane here. Racer 3 following, and also he want to use the left lane and make the turn. So you can see that they are following a very similar path, although sometimes it would be a bit different, but they are using the same model trained using the same set of data set. If we use another model to race with them, the result would be very different. And I can show you.
Okay. Thanks.
Okay, good. So let's try, right? When the other participant is still working on how to make things work on their PC. So I just kill everybody, like here. And then I have to change something here. I just want to NPC. Okay, starting from like 2. Okay. So if I do that and start again, sorry, my bad. So I should be able to see like 2 NPC with the same model joining the race. Okay, Racer 2 and Racer 3. So in this moment, let's try to introduce another PC, and I mean like another car which runs a different model. So let's see what models is available under my car one. So I have previously trained something called job_5. Let's use job_5 to race with these guys. Okay. So how do I do that? Basically, what I need to do is just this. Okay. So we can see Racer 1 joining in soon with a faster model. Hopefully it wouldn't crash. If it crashed, I will have to save him. Okay, don't crash, please. Oh no, oh no. Okay, it is running okay now. So Racer 1 is obviously running faster and a more reckless driver, as you can see. So it's trying to trace Racer 2 and Racer 3. Racer 2 and Racer 3 is kind of like a safety car. So Racer 1, he learned my bad habit of running, you know, like out of the track, but it is running much faster, as you can see. So same thing. Is it smooth when you are watching this, or this is a bit laggy? Okay.
For me, it's quite laggy.
Okay.
But I can see what's happening, so it's fine.
Okay, so we can, unfortunately, Racer 1 has crashed. Let us save it using the mobile app. So at this point, I can even control it, connect it using the mobile app, and like I can ask it to restart again, like using this model. And let's see if it can overtake Racer 2 and Racer 3. So I am, okay, accidentally I start another Racer 1. Okay, I need to stop it first. So, okay, oops, too bad, Racer 1 is gone offline. Let's try to do it again. Okay. Let's see if Racer 1 can come back here and then race with like Racer 2 and Racer 3. Okay, it's back here now. Okay. Oops. So let me give it a little bit help, because like when you're doing like autopilot, you actually can override it using some kind of user control and then start the autopilot again. Again, it is running a bit like off the track, trying to. Sorry, discard. So let's see if Racer 1 could overtake Racer 2 and Racer 3. I've trained Racer 1 being able to overtake Racer 2 and Racer 3 without crashing into it, but it does not always do it successfully. Obviously not now. Okay. Oh, too bad. So it pushed Racer 3 out of the track and itself crashed into the cones. But that's the idea. So you can actually create a faster agent and then race with another slower agent. I've already again rescued Racer 1. And it is taking the corner too aggressively. I did not train it too well, obviously, but that's the idea. Yeah. Okay. So let's see. So let us stop the race. Okay. So is anyone going to race with us? If not, we will end this session soon. Okay. Let me check with. Okay, maybe let's stop here first, and if we have other chance of like organizing a race, maybe we can race next time. So thank you everybody for joining this session.
Thank you.